All right, so looking at this today, we're going to be talking about the focus and the directrix of a parabola. So we're going to look at some new vocabulary, and this is going to help us graph a parabola. So looking at this, we have our parabola over here. We see our vertex, and then two other points on that parabola. So the first thing is the directrix. So that's going to be a horizontal line. And you notice it is outside of the parabola. So it's a horizontal line that is going to be outside of the parabola. So we're going to go ahead and label that. And because it is a horizontal line, when we write this, it is going to be a y equals, because it's a horizontal line. So it's going to be y equals whatever that value is that it goes through on the y-axis. And again, remember, it's outside of the parabola. Okay, and then we have a focus. And the focus is actually an ordered pair right there. And if you notice, that focus is going to be the inside of the parabola. So that is just a point. So because it's an ordered pair, remember when I label my focus, I'm going to label it as an ordered pair, an x and a y. And then that one is going to be inside your parabola. Now, when we're looking at this, what's special about the focus and the directrix? So looking at this, the reason they're special, if you notice here, and you can kind of see those grid lines, but if I look at this, how far it is from the focus to the vertex is actually the same amount from the vertex to the directrix. So this amount right here is equal to that amount. So they are the same distance from the vertex, okay? Sorry. So now looking at this, they're going to be the same distance from the vertex, and that distance is called our focal length. And we represent it with a P. So this is going to be the distance from the vertex to both of those. So distance from the vertex to both the focus and the directrix. So that's the same amount, and that's going to be labeled with a P. Okay, and that is a very important part of what we're going to do today. So that's going to be one of the first things we need to make sure we understand is how to find that p-value. And it is a set formula. Okay, it's going to be the absolute value of 1 over 4 times a. And the reason it's the absolute value, remember, the focal length is distance. And when I'm talking about distance, I'm not going to have a negative distance. Even if I go backwards, I'm still going a distance, and it's always going to be positive. So that's what we need to remember right here. Anytime I'm finding the focal length, your answer is always going to be a positive. Okay, and then one more last part about this. So from here to here, it's that p-value. From here to here, it's that p-value. I need 2 other points to be able to graph my parabola. So even if I have my vertex, I know what that focus is. Notice that focus is in line with those 2 points on the parabola. So looking at this right here, this part is going to be 2 times that p-value, and this is going to be the same. And that's going to give us those other 2 points to connect that vertex, and then so we have our parabola. So this right here is called our LR length. So that LR length is going to help us find 2 other points on that parabola so that we can connect it with the vertex. And notice this, if this is the total length, if I add those 2 sides together, that equals 4 times your focal length. Okay, so I know it's a lot of new vocabulary, but again, that p-value has a set formula that we're going to use to find it. Once we find that, we're going to be able to find all these other parts. Okay, so we're going to practice finding that focal length first. So looking at these, remember I'm using this formula. The p equals the absolute value of 1 over 4 times a. So looking at that, a value right here is 1. So I'm going to do 1 over 4 times 1. That gives you 1/4. So that would be my p-value. Okay, same thing right here. I'm going to take that a value and I'm going to plug it into my formula. So 1 over 4 times -3. That gives you a -1/12. But remember, with this, I am taking the absolute value because I'm looking at distance. So the absolute value of that would be a positive 1/12. So that would be my p-value. Okay. And then the last one right here, I have a fraction for that a value. Doesn't matter. I'm still going to do 4 times that fraction. Okay. And if you need to double check in your calculator, I'm doing 4 times the 1/12. So remember, in my calculator, there's a couple different ways I can put that. I can just use the division bar. Make sure, if you're just using the division bar for your fraction, make sure that fraction is in parentheses. So that gives me a 0.3 repeating. Remember, I'm going to hit math and enter twice, and it's going to give me that fraction. So that's 1/1/3. Remember, another way to get at the fraction, I can do 4 times, and then to get that 1/12, I can also do alpha y equals and hit enter, and it gives me that fraction bar. So then I can type in my fraction that way. Okay, and it's going to go ahead and give me that fraction as the answer. So either way you want to use your calculator, that helps you out. Okay, so that's 1 over divided by 1/3. So now I'm going to divide by that. So I'm going to do 1 divided by the 1/3, and that actually gives me a positive 3. So that would be my p-value. Okay, so this is very important, again, because we're going to use this concept to be able to graph these. So now looking at it, what are we going to do? So the first thing you're going to do is find that focal length. So we are going to find that p-value by using the 1 over 4 times a and making sure we take the absolute value of that. Okay? After we find that, that is going to help us then graph the focus and the directrix. Because remember, once I find that p-value, that's going to tell me how many do I need to go up or down to get to my focus, and then the same for my directrix. Okay? Once you've done that, your last step, you do need to find that LR length, because remember, that gives you the other 2 points. So that's going to give you the other 2 points on your parabola that you can connect with that vertex. Okay, so we are going to label all these parts on these graphs down here. So the first thing I want to do is I'm going to go ahead and label my vertex so I kind of know where I'm starting on my graph. So looking at this, remember, I can look at my equation and say what my vertex is. I'm not adding or subtracting anything. So looking at that, I know my vertex is starting at 0, 0. So I can go ahead and put that on there. So there's my vertex at 0, 0. So now remember, I said the first step is find your p-value. So I've got to do 1 over 4 times that a value, which is 1/8. So I'm going to go ahead and figure what that is. So if I'm do 4 times the 1/8, I get, oops, sorry, I'm not on the screen. I get 0.5, which remember is just a 1/2. So then I'm doing 1 divided by that 1/2. Oops, we don't want a decimal there. And that gives me a positive 2. So that is my focal length. That is probably the most important part we need to find, because now that I know that's my focal length, I'm going to go up 2, and I know that's going to be my focus, because if I look at my a value is a positive, so I know my graph should be going up. So that would be my focal length right there. Sorry, it gives me 2, and then up here I'm going to go down 2, and I know that would be my directrix. Okay, so if I go ahead and label that, my focus right here, that ordered pair, is 0, 2, because I went up 2 from my vertex, because that was my focal length, and then I went down 2 to get that directrix, and that was at y equals -2. Okay, now the only other thing we have to do is we have 1 point of my parabola. I now need the other 2 points, so then I connect them and make that U shape. So that's where your LR length comes in. And remember, that is going to be 4 times your p-value, which is 2. So that gives me a LR length of 8. Okay, so the p-value, you're using 1 over 4 times a, and then for the LR length, you're doing 4 times whatever you get for your p-value right there. So if my LR length is 8, on each side, if I cut that in half, I'm going to have to go over 4. And that gives me my other 2 points to connect for my parabola. Okay, so the focus is on the inside of the parabola, and I knew that was up because my a value is a positive. So I went up 2 to find that focus, and then that LR length tells you that total length from those 2 points. So cut that in half, and that was 4 in that direction and 4 in that direction. All right, so let's try another one. So right here, I'm looking at my a value. Automatically, I know I see a negative I know my graph should be going upside down. So I'm going to label my vertex. Again, I don't see any addition or subtraction, so I know my vertex is at 0, 0. So the first step is go ahead and find that p-value. So I'm doing 1 over 4 times my a value. Okay, and looking at that, we did this one actually earlier. So 4 times 1/12 was 1/3, so this would just give me a negative 1/3, but remember, it's the absolute value of that. So this would come out to still be a positive 3. So looking at that, that tells me from my vertex, I'm going to go up 3. And looking at this, remember, this graph is going upside down. So when I went up 3, that's not my focus. That's going to be my directrix. And then if I go down 3, that one is going to be my focus because I know my graph should be going upside down. Okay, so I can go ahead and label those. My focus is an ordered pair at 0, -3. My directrix is up there at y equals 3. And then the last step, you got to find those two points. So you're using your LR length. So looking at that, remember it's 4 times your p-value. So 4 times 3 is 12. And remember, I want to cut that in half, and that tells me from my focus, I'm going to go over to the right 6. 1, 2, 3, 4, 5, 6. And then over to the left. So your parabola is going to be a pretty wide parabola. There you go. So looking at this, couple things from the beginning, you do need to look to see if it is opening up or if it's opening down. That negative a value tells you it's opening down. We have the vertex, so that p-value we have to find. Now, looking at this, the ones that we're about to do, we're going to start hopefully seeing a connection here. Notice if my vertex was at 0, 0, my focus, that x value ended up being the same. And then here, because it was opening down, that was at -3. All I did was 0 minus my p-value, gave me my new y for my focus. So that one was just 0 minus 3 because I went down and I got -3. Notice on this one, it was facing up, so I did 0 plus 2 and got 2. So these are all connected. So that's going to help us on this next one. So if I look at the next one, a little bit more to it. It's still in vertex form. So looking at this one, my vertex is no longer 0, 0. It's going to be 3, 2, because remember these two numbers represent your vertex. So I am still going to find that focal length first. My a value is a -1. So that tells me my graph is going upside down. And I'm going to do 1 over 4 times a. Now again, that's going to give me a -4. But remember, it's always going to be a positive. So that would be a positive 1/4 for your focal length. Now, this kind of gets a little hard to graph. So my vertex is at 3, 2. So I'm going to go ahead and graph that. If my focal length is 1/4, remember, that tells you that I have to go up a 1/4 and down a 1/4. Well, a 1/4 isn't very long. So looking at that, that 1/4 is going to be kind of hard to graph. And this is going upside down. So that means my directrix is pretty much right on top of that vertex. So that would be right there. And then again, that focus is going to be right there below the vertex. The reason why we kind of talked about right here how your vertex is connected to your focus, because with ones like these, they're kind of hard to graph and kind of hard to see. So we do need to make sure that we can label those. Okay, so thinking about this, if this is my focus, realize it's directly under your vertex. So the x value is the exact same. So those x values are the exact same. Realize my vertex was at 2, and then I went down a 1/4. So if I went down a 1/4, I am going to subtract the 1/4. So I'm going to do 2 minus that 1/4. Gives you 1.75. Let's go ahead and change it back to a fraction. So that would be a 7/4. So if you notice, you started here at 2 for your vertex, and then my focal length told me to go down a 1/4. So I subtracted a 1/4. Okay, now same thing for your directrix. It's going to be y equals, but instead of subtracting a 1/4, I went up for that. So I'm going to do 2 plus the 1/4. And I'm going to change it back to a fraction, so you get the 9/4. So hopefully you can see that connection between your vertex and then using that focal length to get these two values. All right, so the only other thing we need to do now is get that LR length. So it's 4 times your p-value, and 4 times 1/4 is just 1. So that means from that focus, I'm going to go over a half. Because remember, if my LR length is 1, I need to cut that in half on both sides. So I'm going over a half here and over a half here. So looking at that, it's a pretty narrow graph. A little bit hard to graph with those fractions, but that's why it's important for you to understand how these are connected. Okay? All right, and the last graph. This one, unfortunately, is in standard form. And we've already talked about how to go from standard form and get your vertex, because we need to know our vertex. So the first thing you have to find is that axis of symmetry. So remember, this one, a little bit extra work, I have to find that vertex. So I'm going to do the opposite of B over 2 times my A value. Okay, so I'm going to do 2 times 1/4. I'm going to make it so the screen doesn't glare. There you go. So 2 times 1/4. It gives you the 1/2. And I am doing -2 divided by that 1/2. And you get a -4. And remember, this is my axis of symmetry, so it's okay to get a negative. Okay, so I got a -4, which means if I want to find my vertex, I know my x value is -4, I have to find that y value. And we did this last lessons. So looking at that, I am going to go ahead and plug in a -4 wherever there is an x. And that gives me my y value of the vertex. Okay? So now I have my vertex, it becomes just like the other problems. So now looking at this, I am going to go ahead and find that p-value. 1 over 4 times my a value. And then looking at this, 4 times 1/4 is just 1. 1 divided by 1 is still just 1. Okay? So now that I have my p-value, that focal length, sorry, the video cuts me off. And then, so looking at this, I am going to go ahead and graph these. So my vertex is at -4, 1. So then from there, I can go ahead and find my focus. So right here, I'm going to go up 1 to find my focus because it's a positive a value. So that tells me my graph is going up. And then I'm going to go down 1 to find that directrix. Now looking at that, it's right on that x-axis. So my focus, a couple different ways. Again, you can look at the graph, you can look at your vertex. They share the same x value. And then remember, if my vertex was at 1 and I went up 1, that's going to put it at 2. And then for your directrix, looking at that, it's a y equals, and my vertex was at that y value of 1. I went down 1, so that would be at 0. So the only other thing we got to find is that LR length. 4 times your p-value. So 4 times 1 is 4. So half of that would be 2. So I'm going to go 2 in that direction and 2 in that direction. So that gives me my parabola. Okay, so when we're graphing, the most important thing you have to find is that focal length. That focal length, looking at that, tells you to go find your focus, either up or down, and your directrix. So that tells you what direction and how many to go. So now we're going to use the same concept to be able to write equations. Okay, so looking at this, it's still going to help for you to sketch your graph. So given different points, you have to be able to write the equation of these. So if I sketch my graph, I have a vertex at 1, 4. So the vertex is right there. My focus is at 1, 6. So that would be up there. So remember, the focus is on the inside of the graph. So that means the graph is going up. So if I ask you to write the equation, I already know the vertex. And remember, this is vertex form. So all I have to find is that a value. So looking at this, I should be able to find my p-value. Because remember, that's from the vertex to your focus. So how many did I go up to get to that focus? I went up 1, 2. And if I look at those y values, how did I get from 4 to 6? I added 2. So now looking at that, I know that p-value is 2. So we're going to use that. Remember, this is my formula to find my p-value. it has the A value in the formula. So now I can work backwards. So if I know P is 2, I can plug that in, and then it's an equation to solve for A. So if they're dividing by 4 times A, I'm going to multiply it to move it over here. And now to get A by itself, all I have to do is divide by 8. So your A value ends up being a 1/8. So same concept, you have to understand, again, where the focus is compared to that vertex. So remember, it's always on the inside, so this graph is going up. So my A value is a 1/8, so now we need to make sure we can write the equation. So my equation would be y equals 1/8, and then x minus the 1 squared plus 4. So that would be my equation that has a vertex of 1,4 and a focus at 1,6. Okay, so let's look at this one. Same concept. We're going to go ahead and graph the vertex at 0, 3. Okay, we have a focus at 0, -5. So that means I'm going down 5. So there's my focus. And now because the focus is going down, that tells me this graph is going down. So how many to get from your vertex to that focus? So that's 1, 2, 3, 4, 5, 6, 7, 8. So that total length is 8. Okay, so to get from my vertex to my focus was 8. So that means my p-value is 8. So now I can plug it into this formula. So I know 8 equals 1/4 times A. So I can move the 4a to this side. Realize this first step is always the exact same. You're always going to move the 4a over here. So that gives me 32a equals 1. So if I divide by 32, I just get 1/32. Now the key here, remember this a value, this is always a positive number. That distance is always positive. So you have to be careful and realize this graph is going down. So when I write my equation, that is a negative 1/32 x minus 0 squared plus 3. So you have to remember that is a negative because you went upside down. Okay, the x minus 0, realize you don't have to put that. You could also just do the negative 1/32 x squared plus 3. It's the same thing. So either way you want, that 0 is not going to change it at all. Looking at the next one. Now, this one, a little bit different because it gives us different information. So right here, it's giving me the focus at 4, 5. So that's up there. And then the directrix at y equals -3. So that's down there. So it did not give me the vertex, which means I got to figure it out. But remember what we've talked about. The vertex is the same distance to the focus as it is to the directrix. So looking at this, that means the vertex would be in between these two. So if I start here at the directrix, I go up 1, 2, 3, 4, 5, 6, 7, 8. So that total length is 8. Looking at that, the vertex should be in the middle of that. So what is half of 8? That would be 4. So that means my vertex from here would go up 1, 2, 3, 4. And remember, it is always directly lined up with the focus. So that would be my vertex because it goes 4 to the focus, 4 to the directrix. So that point is 4, 1. So we had to find our vertex. And again, you have to use the information that the vertex is in the middle of the focus and the directrix. So now it becomes the same thing we did over here. We just found our p-value. So if this is my vertex right here, between these, that's 4. So now I can use my formula. So I have 4 equals 1/4a. Multiply by 4 on both sides. So that gives me 16a. And then divide by 16. So I get 1/16. And realize, because the focus was right there, it is going up on that graph. So when I write my equation, I have y equals 1/16 x, and remember this is my vertex I just found, x minus 4 squared plus 1. So that one, you had to find the vertex and realize it is in the middle of your focus and your directrix. All right, last one. Similar to the first two, but instead of the focus, they're giving you the directrix, which again, it doesn't matter because remember, the focus and the directrix are the same distance from that vertex. So my vertex is at 2, 1, and then this is at y equals 4. So that is going to be up there. So that tells me if the directrix is up here, this graph is going down. So how far from that vertex is that directrix? So that would be 1, 2, 3. So your p-value is 3. So looking at that, go ahead, plug that in. So I'm going to multiply by 4a on both sides, and then divide by 12. So you get the 1/12. Okay? So my equation would be y equals, and remember it's going down, so I'm going to be having negative 1/12 x minus 2 squared plus 1. So that would be my equation. So a couple different steps, but again, it is making sure you understand the concept of where the vertex is compared to the directrix and the focus. Okay? Last thing, we're going to look at a word problem. Again, it's the same concept. It's just putting it into more words. So this one is you're talking about solar dishes. You're talking about right here, it says to concentrate sunlight onto a high efficiency engine located at the reflector's focus. So that is a key word right there. The sunlight heats a substance such as water or helium and the engine provides electricity. Suppose the cross section of a reflector has an engine that is 4.5 meters from its vertex. So write an equation for the cross section of the reflector. So this right here, pay attention to what that's giving you. We are going to pick the vertex and we're going to choose it to start at 0, 0. Okay, so looking at that, we're going to pick the vertex to start at 0, 0. The 4.5 meters away, so if this is my vertex right there, that means it's about right there, 4.5. That's telling you your p-value. So that's giving you your p-value. So it's actually done a little bit of work for you. So again, we're going to do the same thing. My p-value is 4.5. So I am going to plug that in. So I am going to do 4.5 times 4, and you get 18. Divide by 18, so you get 1 over 18. So there's your a value. Okay? So looking at this, if that's my a value, I can plug that in. My vertex is at 0, 0. So remember, I can make that just x squared. Okay? So you just have to understand the information that it's given you. Again, this is telling you your p-value, so you're good there. Okay? So with a focus and a directrix, make sure you understand the concept of where they're located at in your graph. The focus is always going to be the inside of the graph. The directrix is a line that is outside of your parabola.